Hey students, this is lesson 732. We're going to learn how to solve problems using systems of equations. The idea is here that we write a set of two equations that we can then solve. And once we have the equations, I'm going to say you can go ahead and use your graphing calculator and just make a graph, find where they intersect, and there you go. You'll have the solution. But let's look at this explore problem here. Two bookstores each fill catalog orders. Each charges the standard price for the books, but they have different shipping and handling charges. Gaslight Bookstore charges a shipping fee of $3 per order, plus $1 per book. Crime Scene Bookstore charges $5 per order and 50 cents per book. For each bookstore, write an equation that describes how the shipping cost Y is related to the number of books X, then graph both equations on the same axis. So we have two different bookstores, Gaslight and Crime Scene. All right, Gaslight charges $3 per order plus $1 per book. So for every order, the price for one order, that's Y, is going to equal $1 per book you buy, and we're going to say we're going to let X stand for book. So $1 per book. So we can just multiply 1 times the number of books plus $3. And the other bookstore, Crime Scene, charges $5 per order and 50 cents per book. So that equation would look like this: 50 cents times X plus $5. All right. Now, if we graph these two, they have different slopes, so they're going to have different lines. So let's go ahead and do that. So I entered those two equations on my calculator, and I'm going to press graph, and here's what I get. Now, sometimes your graphing calculator won't show where they intersect, which is really a point that you really want to see. So you can change your window or zoom out, however you want to do that, to get that window to show up better. And I'm just going to go to my standard window, and hopefully it'll be there. Once I have it here, when I'm talking about the number of books I bought, I'm really talking about positive numbers. And all these numbers here and here are negative. I really don't need those. What I'm saying is an appropriate window here would be just go from 0 on both the X and the Y axis. And then graph it. So that looks like this. And we can see that the two lines intersect. All right, let's check out what we want to figure out about this. So the next question says, under what circumstances would you order from Gaslight? When would you order from Crime Scene? Are there circumstances when it makes no difference from which store you buy? We're talking about cost here. Is there some cost that is going to be the same for both? And if we look closely at the graph, we can see all that. I'm going to press trace here. And right now I'm on Y equals X plus 3, which is Gaslight. And you'll notice that it's above the other line here. If it's above that line, that means it costs more, because Y is how much it costs. If I go down to the other one, you can even see at that point it costs $7.60 and $8.21. So, but if I go to the other side of this place where they intersect, you'll notice that the Gaslight cost becomes less, like down here. If, say, I order about 2 books, it costs about $5, and the other one costs $6. So you can see it's $1 cheaper there. And there is a spot right in the middle, right there, where the cost is the same for both. It looks like about 4 books shipped. Remember, X is 4. So, and remember, you can also use your second trace and find the point of intersection. That really tells us everything. Once we know where they cross, we know that before where they cross, the one equation is going to have lower Y values, which in this case is cost. And if you go past that point of intersection, then the other equation becomes lower cost. So the important thing is when x equals 4, the cost is the same. In other words, for 4 books. When x is greater than 4, the cost is cheaper at crime scene. When x is less than 4, the cost is cheaper at Gaslight. All right, we're going to do a couple more problems here. Some of these we'll just do in class, but I'm going to go to just give you some examples that I want you to do. Let's go to right to where it says homework, and we'll do this pizza problem. So our goal here is to write 2 equations that represent that. All right. So Antonio's Pizza charges $8 for a large pizza, $1.50 for each topping. Zena's Pizzeria charges $10 for a large pizza and $1 for each topping. Write and solve a system of equations. So let's say that toppings are x. And then we'll write an equation and we'll say y is the cost. And we have 2 pizzerias. We have Antonio's and we have Zena's. Antonio's charges $8 for a large pizza and $1.50 for each additional topping. So the cost at Antonio's, y, is $8 plus $1.50 per topping. So we're going to multiply $1.50 times the number of toppings plus $8 for that one. And Zena's, we are going to do $10 for a large pizza plus $1 for additional toppings. So that's $1 times the number of toppings plus $10. Okay, and then our question says, for what number of toppings would the pizzas cost the same? In other words, will we get the same values, y and x, for both of these? And again, we can use our graphing calculator to do that. So we're solving this system of equations. And y equals 1x plus 10. And we're going to graph it and look for where they cross. So I'll put that on my calculator. I have those 2 equations in my calculator, and now I'm going to press graph. And my screen is only showing one of the equations, which means, and if you think about it, the y-intercept is 10 for one of them. Another way that you might set up your screen is look at your table too. We want to know when the cost is the same, and you might notice that the costs are the same at 4 pizzas. Both of them cost, or 4 toppings, both of them cost $14. And we're not really showing that because our y is 14 and our y max only goes to 10. So I would just quickly change this to 20 and then graph it. And we can use the trace button. And once you know where it's close to there, then you can use second trace to get more accurate by doing the intersect and press enter 3 times. And at 4 toppings, both pizzas cost $14. Okay? So 4 toppings is the answer. And the cost is $14. All right. I think we'll do one more here, and then the rest we'll do in class. Let's do this. Let's do this money problem here. All right. Let's do this money problem. It says Harvey has some $1 bills and $5 bills, and all he has 6 bills worth $22. Let x be the number of $1 bills. Let y be the number of $5 bills. So let's just remember x is the number of $1 bills, and y is the number of $5 bills. Y. Write a system of equations to represent the information and use substitution. I'm going to change that. We're going to use graphing. Use graphing to determine how many bills of each denomination. All right. So we're going to do The first equation that we're going to write is that we know he has 6 bills. And remember, X is the number of $1 bills and Y is the number of $5 bills. And we know that there's 6 bills in all. So that equation looks like this. X plus Y equals 6. We're just adding up the bills, not how much they're worth. Okay, so the two numbers add up to 6. And then the other equation we're going to get has to do with their value. To get their value, and just think about this, if you had some $1 bill or $5 bills, one way to get that value is just to count how many $1 bills you have and multiply those by 1. Then count the number of $5 bills you have and multiply that by 5, and then add the two together. So that would look like this. 1x plus 5y is equal to 22. All right? And 1x, of course, is the same as just x. So we have two equations here and two variables, so we should be able to solve this. And we're going to use graphing to solve this. The way we're going to do that, we're going to, you can do it one of two ways. You could, if you had graphing paper, you could find the intercepts and graph it that way. I think we're going to use a graphing calculator, though, which means we need to solve each of these equations for y. So let's do that right now. To solve this one for y, we just need to subtract x from both sides. So y is equal to 6 minus x. And to solve the other one for y, we're going to subtract x also, which gives us 5y is equal to 22 minus x. And we're going to divide by 5. And remember this, when it's just x, it's actually 1x, so that's going to give us the equation y equals 22 divided by 5 is 4.4, and 1 divided by 5 is 0.2, so minus 0.2x. Now we're going to put those two equations on our calculator. So here I have them on my calculator, those two equations. We now want to graph it. And graphing, to graph those two, I have a little more window than I need, so I'll just shrink that up. My y max is more than it needs to be for this problem. I think I'm going to go to 10 there, graph it. Then I'm going to trace and find the place where they intersect. Do second trace 5, enter, enter, enter. And it says x is 2, y is 4. Let's think about that. So if x is 2, that means I have 2 $1 bills. And y is 4, that means I have 4 $5 bills. And if you think about adding those up, that's $2 for the $1 bill plus 4 times 5 is 20. And that adds up to $22. All right, that's the end of the video. I'll see you tomorrow.